This is Miss Sherry giving you a little refresher on the Zorro method. You can go ahead and Google Zorro. He was quite popular many years ago. Even I'm too young to fully appreciate who Zorro was. But if you check out how Zorro is swishing his blade there in the Z, that kind of goes with why this is called that method. So start with a little funny. 4 out of 3 people have trouble with fractions. Does that include you? So the Zorro method works with adding and subtracting fractions. When you're multiplying and dividing, ignore. So we're going to practice this now with fractions so that when you get into more algebraic type work and you've got lots of variables, you will know how to do it when the answer isn't a number that you can just check. So for the Zorro method, we're making 3 swipes, kind of like Zorro with his Z, how he makes the 1, 2, 3. Ours is a little different than that. But the first swipe goes on the top of your fraction, the second is on top, and then the third is the bottom. So this is just the template. And I'll talk to you about whether there's a plus or a minus in this location next. So go ahead and get that template down so you know step number 1 goes here, step number 2 goes here, and step number 3 goes here. So go ahead and pause if you need to and then restart the video. So for instance, we have 2 fractions, and as you can see, we are subtracting them. So first, let's do our keep, change, change. We still use that. Or add the opposite. So we're going to add the opposite. Remember that we talked about fractions, that if you have a negative fraction, it's the same thing as the top number being negative or the bottom number being negative. I usually choose to make the top number negative, but if you make both of them be negative, then -1 divided by -2, well then that follows this rule that if you have 2 negatives, it's actually positive. So you can't do that. One number or the other. So you should have notes on that in your interactive notebook. So we talked about our first, second, and third swoops. So the first one is down to the right and you multiply. So our first one gives us 3 times 5. Our second one is down to the left, and that one gives us -1 times 4. And our third one takes us across the denominators, across the bottom, and that is 4 times 5. So if we get our lines in here, so we've got steps 1 and 2 are part of the numerator, and we are adding right here, so we're going to add right here. And then step 3 gives you your denominator. So 3 times 5 is 15, plus -1 times 4 is -4, and then 4 times 5 is 20. So 15 plus -4 is 11, and our 20 stays like that because we already did the math there. And 11/20ths, 11's prime, so there's no lower terms to put that into. So step 1 is down to the right and goes here. Step 2 is down to the left and goes here. And then step 3 is across the bottom and goes here. So when you go down to the right, you start here, and that's where the number goes. Down to the left, you start here, and then your number goes in the upper right. Across the bottom, and your number goes in the bottom. Let's try another one. So again, here, this one we happen to be subtracting. If you're adding, you just leave it and add like normal. But here, we are subtracting, so we're going to keep, change, change. So we're going to add the opposite. And let's set up our format here. So step 1, -5 times 3 is -15. Step 2, -8 times 4, which is -32. And then step 3, 4 times 3, and that's 12. Now we need to simplify. -15 plus -32, it's -47, and our 12 stays like our 12. And then we can turn that into a mixed number. So we'll use that top in the box trick. And since we've got one negative number, that still goes with this trick here. We're dividing, we've got a negative and a positive. So our answer is negative, so we can get our answer box ready and put a negative in it so we don't forget. So 12 goes into 47 3 times, almost 4. And we subtract and get 11. And we're doing fractions. That's our format, so we're not going to put a decimal point in zeros. We're going to keep it as a fraction. So we've got -3 and 11/12. And that's our final answer. So another one here with keep, change, change. This time we happen to have a negative in the second number. So when we add the opposite, now we've turned it into a positive plus a positive. So let's set up our format here. So our first step, 15 times 2, which is 30. Our second, 3 times 9, which is 27. And our third, 9 times 2, which is 18. 30 plus 27 is 57 over 18. And we have to do top in the box again. So 57 divided by 18, or we could divide them each by 3. 5 plus 7 is 12, and 1 plus 8 is 9. So both numbers are divisible by 3. So you could do that if you'd want to and make smaller numbers. But 18 goes into 57 3 times. And 3 times 18 is 54. Subtract and we get 3. So 3 and 3/18. Well, 3 and 18 can both be divided by 3. So that gives us 3 and 1/6. And we were dividing two positive numbers, so our answer is positive. So with the Zorro method, we're starting practicing that with numbers, because then you could make common denominators and double check your answer, because once you get to more of an algebraic situation, oopsie, if you have 2a over -3 minus -7 over 4b. So the Zorro method comes in very handy so that you're not having to find a common denominator between -3 and 4b. You can simply do step 1, this times this, step 2, this times this, step 3, this times this. And if you then want to keep a subtraction sign in the middle, you could do that instead of keep, change, change. But at this point, I think you still would benefit from our keep, change, change to try to eliminate out that. And then we've got plus a positive. So anyway, that's the kind of problem that will be coming up with the Zorro method. So if you need to rewind and rewatch, and you could also make your own practice problems, you could try with fractions that you know, like 3/4 plus 1/4 is 4/4 or 1. Try it out. Try the Zorro method and see, do you end up with 1 as your simplified answer? So try easier problems that you know, or 1/3 plus 1/3 is 2/3. Try the Zorro with it and see, do you end up with 2/3 when you're all finished? Math rocks and so do you. Thanks, and I'll see you next time.